Okay, so yes, welcome. Thanks for being here. The final RailsConf, and especially after such an incredibly moving and wonderful keynote by Aji. I don't know if a conference talk has ever made me cry, but it did. Just a wonderful celebration of Rails and of our community. So awesome job, Aji. Show of hands, who attended RailsConf in 2012 in Austin? Wow, there's not a single hand. Okay. Oh no, there's one. Okay. Yeah, 2012 was my first RailsConf. And I actually spoke at that one too about internationalization. And for that reason and so many more, it's an absolute honor to be chosen to speak at this, the very last RailsConf. So thank you for being here. Thanks for making the Rails community a place that I have wanted to stay a part of for the last 15 years. Back in 2012, I had just gotten a new DSLR camera. I took some photos of the conference because I took my camera everywhere because I was so enamored with it. And I'm looking through the pictures I took, trying to find one that might sort of fit in for this talk. And I found this one. And I didn't know who any of these people were at the time, but they seemed important, so I snapped the picture. And the thing that strikes me now, looking back, is just how wet David looks. Like, I don't know, did Evan throw a cup of water on him or something? I don't know what happened there. Anyway, it's good times. Before I really go into introductions about who I am, though, I think by way of introduction, I'd like to share some screenshots of my GitHub contribution history. This is probably how we should all introduce ourselves, right? So we'll take a look at this real quick. 2018. I'm not actually sure how GitHub counts contributions, if this is commits or what this is. But this is 2018. And then in 2019, 311. And then a big jump in 2020, 603, 616 in 2021. And then finally a whopping 1,045 in 2022. And I'm not standing up here trying to say like I'm an amazing open source contributor. I'm just trying to show this interesting data pattern and sort of explain, it'll become clear sort of why I'm talking about this in a second. Let's also look at some events in my life that may sort of, overlay onto this to see what was going on at that time. We can also see the delta here, so that's a change of 79 for those first 2 years, a big one at 292, just 13 later, and then the last one is a big jump for 429. So what were some things going on in my life? Well, in 2019, my first daughter was born in December, and in 2021, my second daughter was born. And you might be thinking like, that's weird. Shouldn't he have less free time to work on open source? And I was really baffled at this too. Kids take up so much of your free time. But I think the pattern is like relatively obvious here. You would think that, I firmly believe that the reason for these big contribution spikes is precisely because my time was so constrained. We've talked, I think we heard Aji talk about constraints as well. That's one of the big thrusts of this talk, is that constraints actually lead to higher productivity. I didn't have a commute anymore back in those days, starting in 2020 or so, because of the pandemic, and most of my time on holidays and weekends was spent taking care of my kids. But I would think about my side projects, like in the shower and during breakfast and other times throughout the day, and decide exactly what I was going to do next. When I got 30 minutes of free time, I would sit down on my computer and I could actually really start working on the feature or whatever right away. So I got better over time at picking tasks that could fit into the time that I had available and at working out the logic in my head before sitting down at my desk. So my open source work time became more focused, it became more deliberate, it was guided by the forcing function of this severely constrained schedule. And I started seeing this sort of phenomenon in other places too, and it reminded me of this Leonardo da Vinci quote. He said, "Art lives from constraints and dies from freedom." And in my own experience, I've found this to be extremely true. But I also think that history is sort of rife with examples of this as well. So take the Concorde supersonic jet. Concorde was the first, and I think only, supersonic commercial jet. It took decades to build and had to overcome a series of really huge technical obstacles before its first flight. One of these challenges was temperature fluctuations. It had to be designed to withstand temperatures ranging from negative 55 degrees centigrade at high altitude to 160 degrees during supersonic flight, which required specialized materials, design solutions to manage thermal expansion and contraction. It also had to be more fuel efficient. Supersonic flight is significantly more fuel intensive than subsonic flight. It had to be more aerodynamic than previous aircraft. Its innovative and iconic droop nose was invented to enhance pilot visibility during landing, but presented aerodynamic challenges. And its wing design, while optimized for high-speed flight, made it less efficient for takeoff and landing, requiring higher speeds and special handling techniques. The thing is that despite these many engineering challenges, Concorde was built successfully, and it flew for years. In fact, I don't think it's an exaggeration to say Concorde was one of the greatest engineering achievements of the last 50 years. And I think that that's largely due to the number of constraints placed on the Concorde team, forcing them to focus on the right things. Speaking of engineering greatness, let's take a look at another example of what I would call art or engineering greatness thriving under constraints, and that's the Apollo 11 flight computer. You've probably seen this photo before. This is Margaret Hamilton standing next to the code that she and her team wrote in the late 1960s. The computer system that they had to work with was extremely rudimentary by today's standards. They had 72 kilobytes of memory, not megabytes, kilobytes. They actually had to hand weave wires for additional storage. There was no product you could buy off the shelf for this, but even that was very limited. The whole thing was programmed on paper punch cards. And it was also innovative in the sense that it was maybe one of the first systems built that had built-in fault tolerance. And for that reason, it actually never failed, never had a catastrophic failure during flight operations. And I don't know about you, but I have seen apps that use untold numbers of gigabytes of memory that fail all the time. The constraints of the environment and the available technology guided the Apollo development team, I think, by allowing them to focus on specific technical problems and disregard others. In Hamilton's own words, there was no choice but to be pioneers. The things they were doing had never been done before. But while the limitations of Apollo 11's hardware seemed like they should have been a barrier to success, I would argue they directly led to success. More constraints lead to increased focus, and increased focus leads to incredible outcomes. But even if you don't buy the argument that constraints equal achievement, we tend to think of achievement as more impressive when the goal seems impossible. And I think that psychologically, many of us are drawn to doing hard things because we know that if we succeed, we will really have done something. Okay, so what does all of this have to do with Rails? So around my first RailsConf in 2012, DHH published this seminal blog post. Show of hands, who has read Rails is Omakase on DHH's blog? Yeah, even today I feel like it's one of those extremely well-known and influential blog posts. It was a big topic of conversation back in the day when it came out. Here is a quote that sums up the main idea. A team of chefs picked out the ingredients, designed the APIs, and arranged the order of consumption on your behalf according to their idea of what would make for a tasty full-stack framework. He introduced, I think, many Rails devs to the Japanese concept of omakase, which means leave it up to you. In a restaurant setting, omakase is letting the chef decide what you eat, rather than you deciding it from a menu, for example. In the case of Rails, omakase means letting the core team decide what to put in the framework, such that the whole thing can be used to build an application quickly and easily. Rails is explicitly designed to take away choice. As we've seen, while that might initially sound like a bad thing, it's very much a good thing. It places constraints on you, the developer, and drastically limits the number of decisions you have to make to get up and running. This is one of Rails' biggest and most valuable ideas. Rather than spending time deciding how to configure a library to talk to a database, you just use Active Record. Active Record is a constraint. It might not be perfect, but it's the default and it works most of the time. Just as large temperature fluctuations guided Concord's engineers toward the lightweight, durable fuselage material for their aircraft, so does Active Record guide developers toward battle-tested database access and persistence patterns for their applications. Let's take a look at a few of the ways that Rails limits decision fatigue through constraints. One of the big ones is folder structure. It's a place for every file. If you don't think this is a big deal, just talk to your favorite React developer. Mini-test, there's no need to configure a test framework or bolt it on. Mini-test is built right in. It works great. Of course, all the sub-frameworks, we talked about Active Record, but there's also other frameworks for performing work in the background, sending email, communicating async with the front end, et cetera, et cetera. And of course, maybe some newcomers, Stimulus, JavaScript sprinkles, no need to add any third-party libraries, this just works. Cobble for straightforward deploying. Thruster, the fast HTTP proxy that came out a few years ago. And then we're also now seeing, I think, even more innovation or simplicity rather in the form of SQLite-powered projects like SolidQ, et cetera. A whole new era of simplicity around the database layer that removes the need to run a separate database server. So this batteries included, Omakase, constraint-driven approach is such an important idea that other frameworks and communities are starting to discover this organically, which is surprising to me because it's been there the whole time, but it's kind of an unusual. I think other communities are now finally starting to get this. This is a tweet I posted a few years ago after listening to an episode of the Changelog podcast where the authors of the Dino framework, or the Dino runtime, or a framework rather, that's written for Dino called Fresh, were going on and on about things like server-side rendering and routing and middleware. And as a Rails dev, it made me just kind of shake my head like we would had this for years, right? I guess we had to go through a cycle or something so that old ideas could become new again. Here's Luca Casanata from that episode describing Dino's approach. He says, one of the core ideas of Dino is to have this whole batteries included runtime and a million other things all in the same binary maintained by the same people with the same opinions to sort of give you a cohesive experience. Once you've used it, you realize how much time it saves you by not having to make all these decisions, but to have someone else make the decisions for you. So again, talking about decisions being made for you, constraints being placed on you as a really good thing. Other communities have also figured this out. So that really begs the question, like, what is a framework then, really? And I think, based on my read of frameworks over the years, that a framework is really just a series of decisions made for you. And I believe that for that reason, frameworks are sort of omakase by definition. Which, of course, brings the question then, what's the opposite of a framework? Opposite of a framework is where you, as the developer, make all the decisions. There's actually a Japanese term for the opposite of omakase. It's okonomi, which means how you like it. And this is, in other words, this is choosing what to order instead of letting the chef do it for you. So this is how most of us are probably used to eating at a restaurant. Find something you want on the menu, you order it, the chef makes it for you, what you asked for. And if you think about it, this okonomi style, where you decide what to order, describes a lot of the tooling in other language communities like JavaScript. Here's a Reddit post I found that sums up what it's like to work in JavaScript heavy stacks, and this definitely mirrors my experience. This poster says, you don't want to include DOM types in your node library? Well, now you just disabled the import of @types. Want to use ES6 imports? Yeah, suddenly it doesn't work because somewhere down the node modules tree, some package uses CommonJS requires. All the solutions are some old answers on Stack Overflow that don't apply anymore or don't work. Let's scroll down and look at the very first comment. This guy says, this is literally my whole career. Yeah, that tracks. So I don't want to bag on JavaScript because I actually like JavaScript, but I do think that a lot of these smaller tools that weren't designed to work together are kind of a problem. And let's take a look at front-end dependencies. This is sort of independent of any framework. And specifically, let's look at starter kits. So As I said before, the JavaScript community tends to value lots of small packages, kind of the Unix philosophy. So let's look at the number of dependencies that these starter kits bring with them. So create next app, okay, not horrible. React router, 285. Redwood, 478, that's starting to get pretty high. And then create React app weighs in at over 1,300 dependencies. These aren't all gonna make it onto the front end, but a good deal of them do. And that is just an enormous number of dependencies that could make it potentially come out and get loaded on your front end. It's sort of given rise to this meme, which I really like. So let's look at some front-end decisions that you might have to make in 2025. And again, this is sort of framework agnostic here. You have to choose a JavaScript package manager, and there are numerous package managers these days. Of course, NPM, Yarn, or PNPM, but then even within those, for example, for Yarn, there are different sort of versions of that as well. 1.x, and then everything after that is called Berry, I guess. Why it's called Berry, I don't know. You might want to choose a bundler system, and you have lots of choices there. Bun, an ESBuild, a rollup, or webpack. Maybe you want to use importmaps. You might want something for your like a CSS, either framework or build system. Tailwind, Bootstrap, Bulma, PostCSS, dart-sass, the list goes on. Do you want to use Typescript? DHH would say no, but a lot of people want that. Are you going to choose a CSS methodology? Is it BEM or SMACSS or OOCSS or Cube or HECS? Or maybe you want CSS modules instead. You've heard those are cool. Are you going to choose a front-end framework like React or Vue, Angular, Svelte, Solid, Lit, Stencil, tons of choices there as well. Or maybe you want to try HTMX, or maybe you want to try Inertia. These are all decisions that you have to make. There are over 16,000 combinations of just these few decisions that I wrote out in the previous slide. And that means that there are over 16,000 ways to configure your front-end system. This is the opposite of Omakase. Let's look at the problems inherent in these front-end setups. You end up making decisions all the time instead of actually working on your app. Build failures come in the form of useless error messages and stack traces deep inside transpiled dependencies. Tools don't work well together because no developer accounts for all 16,000 permutations. Debugging is hard because there's almost no indication of what actually went wrong. And upgrading is hampered by release cycles that don't match up and exacerbated by the sheer number of dependencies. Okay, so these problems I would generally associate with JavaScript first or JavaScript heavy front-end setups. And for a long time, Rails avoided most of these pitfalls. But let's take a look at the history of the Rails front end. As I sense, some of you have not seen the history before. So in Rails 3.1, before Rails 3.1 and even including Rails 3.1, there really was not much of an asset story. It was static files. You'd write some JavaScript, some CSS, you'd link those static assets in your head tag potentially, and that was how assets were delivered. In Rails 3.2, we got sprockets, the Rails asset pipeline. A lot of people sort of love to hate on sprockets, but I think sprockets is awesome, and it was way, way better than what we had before. In 2014, Rails sort of added webpack as optional because these module bundlers were becoming a big thing in the JS world. And then in 2019, there was webpack became the default, and sprockets was kind of on its way out. So fast forwarding a few more years, in 2021, we start to get a little crazy. So now, as opposed to sort of one thing, now there's 4 things. CSS bundling, JS bundling, import maps, prop shaft. It's a lot less Omakase and a lot more okonomi. And you might think, okay, well, these things seem simple maybe, but it's actually hiding a lot of complexity. CSS bundling isn't just one thing. I can't drop it in my app and suddenly write some CSS and it works. Instead, I have to make a choice between Tailwind, Bootstrap, Bulma, PostCSS, or SASS. Same thing is true of JS bundling. I have to make a choice here. Do I want to use, ESBuild or Bun or Rollup, Webpack? And I think what this is really showing is that the Rails front-end story could be a lot more cohesive. Okay, so that was a huge amount of content, and now I'm going to introduce me. So I'm not someone who likes to share opinions widely, but that's what the next part of this talk is. So you might as well know who I am and maybe why I should be taken seriously. So my name is Cameron Dutro. I used to work for GitHub. I worked on the Vue component framework. And I also worked on GitHub's Primer team, where we worked specifically on Primer Vue components, which is a large collection of components for the Primer design system. I also am the author of Rux, which is a front-end framework or a front-end templating language that lets you write JSX style HTML snippets in your code for your templates. And I'm also the author of several pretty complex Vue components, so I feel like I kind of understand a lot of the current front-end issues. I've also done some other crazy things. I tried to write a Ruby interpreter in Typescript. If you want to talk about that, it's called Garnet.js. That was a lot of fun. And I do have a lot of front-end opinions, sort of as a result of this work recently. I don't like sharing opinions that much because I think they often don't come with qualifiers or nuance. But that said, I do have a lot of opinions, and I want to share them with you today. So yeah, these opinions are based on all the work that I've done over the past 4 years, working on component frameworks, design systems, and I believe that most of these should be Rails defaults. So warning, opinions are incoming. I'm going to go through these rapid fire at first, and then talk about them in more detail later. So for a better time, use NPM. Use a build system. Use Vite. Use PostCSS and BEM, block element modifier. Use TypeScript. And finally, use web components, Stimulus, and Hotwire. For a better time also, avoid these tools. Don't use importmaps. Don't use webpack. Don't use a JavaScript framework. I'm going to go into a lot of detail on that one later. I also don't know if you really, I took this out, but I had it in there before. Don't use Tailwind. I think a lot of people like Tailwind, so I'm going to not say that. I personally think that developing your own set of utility classes is more powerful, but I'm not going to put that on the record. Okay, so why NPM? So NPM is OG, and it used to be kind of bad, and other packaging systems were sort of overtaking it. But it's really good now. This is actually to the point where GitHub had switched from Yarn to NPM, not just because the company bought NPM, but also because it was just much better than it used to be. So no, really, NPM is good now. Give it a shot. Yarn 1.x, which is, I think, what most people that aren't using NPM are using, is basically unmaintained at this point in favor of newer versions. But I have personally had really bad experiences with Yarn 2+. Like, I just cannot get it to work half the time, especially version 4 for some reason. So I've always sort of stuck with Yarn 1x when I have to use Yarn. But again, I would say NPM is the way to go these days. You talked about use a build system. No build is really cool, but we are not there yet. You need a build system. I'm just going to come out there and say it. Maybe one day we can use import maps for real, but that day is not today. But don't take my word for it. Dave Thomas agrees. Here's a tweet he posted just a few weeks ago. He says, "I'm sorry, Rails, but propshaft/import map isn't a happy experience. When it works, it's magic, but stray just a little from the happy path, and you get no insight into what's failing and where." Okay, so as an antidote to that, use Vite. Vite is a combination of two different tools. It uses ESBuild in development and it uses rollup in production. ESBuild is extremely fast. It makes development really nice. All that it's really doing is concatenating behind the scenes. It also has built-in TypeScript support. Rollup is slower, but it's battle tested, and you only have to do it for prod, so there's no sort of waiting in development for it to compile. I like to say, love yourself, use Vite. But again, don't take my word for it. Listen to Dave. He says, "Finally had a chance to get started with Vite Rails. 20 minutes in, and I've got all the external CSS and libraries loaded and running. No fuss, helpful errors, and fast." That's a pretty good recommendation, I think. Okay, PostCSS. This is a PostCSS, if you're not familiar, is a CSS transpiler and toolkit. I would say that PostCSS is pretty industry standard at this point. It's got a lot of momentum behind it, a lot of great tooling in it. It also has a really nice and rich plugin ecosystem if you need to leverage that. And the Rails generator for this, which comes with CSS bundling Rails, will add several of these imports for you, or several of these plugins for you, including the ability to import other files, nesting like you might get with SASS or SCSS, auto prefixing for vendor prefixes and whatnot. And I would go so far as to say, because of this, you don't really need SASS or SCSS anymore. PostCSS can do all of this stuff for you. Next, use TypeScript. Don't listen to DHH. TypeScript is wonderful, and I personally have found much usage in it and utility in it. I wish that Rails and Ruby had more typing. It just works out of the box with Vite. Vite automatically has TypeScript support, not to configure anything. And if you don't want to use it in some particular cases, you can just use a JS extension instead of a TS extension. No problem. Yeah, enjoy the power of types. They are amazing. There's a reason that a lot of other languages are typed. Use Hotwire, Stimulus, and web components. This is the Rails way, so that's one of the big reasons to use them. They're going to be supported for hopefully a long time. They really require no extra dependencies aside from what you get with Rails New. They just provide a lot less bloat, I would say, than the frameworks. And one of the big benefits too is they don't take over the whole page. You can specify individual sections of the page that have these JavaScript sprinkles. And they also, and this is also a big plus, they leverage the web platform. Web components, HTML over the wire, these things are all built into web standards. They are not bolted on like React would do. Okay, now, the other big part of this that I mentioned that I was going to go into more detail on is that you probably don't need a JavaScript framework. Now, I know in the Rails community, I think we have heard this a lot, but it still is so true in today's world. I think JavaScript-heavy front ends have kind of gotten out of control. And they're leading to poor experiences for consumers, especially those using lower-end devices or accessing the internet over slow connections. This is a quote from Alex Russell, who has an excellent blog, Infrequently Noted. He was a software engineer at Google. He worked on the web platform and the Chrome browser for over a decade. He's now a PM on the Microsoft Edge team. And on his website, he claims that his professional mission is to build a web that works for everyone. And Alex often publishes research around web performance and is known for his biting criticism of poor web performances, often the result of over-engineered front ends. So in a recent blog post, Alex writes, "To serve users at the 75th percentile of devices and networks, we can now afford 150 kilobytes of HTML, CSS, and fonts, and 300 to 350 kilobytes of JavaScript. That's not very much. And this is a few years old, but I think these numbers have not changed that much in the intervening years. And yet, a number of the most popular websites and important websites out there have absolutely tremendous amounts of JavaScript in their payloads. A popular article published on tonsky.me blog a few years ago sort of categorized some of these and described how crazy things are getting. Zoom comes in at 6 megabytes. Now, this is not the Zoom app. This is just the Zoom splash page on their website and like a login link or something. Why you need 6 megabytes to do that, I don't know. Patreon, 11 megabytes. GitLab, 13. Again, that's just the login page. It's not even the whole thing, like the actual app. Instagram, 16. LinkedIn, 31. And then for some reason, Jira coming in at 50 megabytes. Like, why? That's insane. So yeah, this has gotten absurd lately. And just maybe to drive the point home even further, here's a tweet that I found. This guy says, if you load this page being a Forbes article, it contacts 82 IP addresses, executing 256 separate HTTP transactions to download 18 megabytes of data, writing 64 cookies to your device, tell you no, Mission Impossible: The Final Reckoning does not have a post-credits scene. So JavaScript frameworks, I'm just going to come out and say this straight up, are hurting the web. In another one of his blog posts, Alex Russell writes, frameworkism isn't delivering. The answer isn't a different tool, it's the courage to do engineering. Now, I don't necessarily want to come up here and say that applies to Rails. I think it's mostly about JavaScript on the front end. But I think this really clearly illustrates that you really only need to reach for, or you should only reach for a JavaScript framework when you actually need one. And most applications do not need one. So what's the bottom line? Use NPM, Vite, PostCSS, TypeScript, Rails defaults. If you take nothing else away from this talk, I would say use Vite is the biggest one. That is such an easy, so yes, definitely use Vite. avoid React and other frameworks unless you actually need them. Do engineering. Okay, so I would be remiss in this presentation if I didn't also have some code for you to look at. So I don't know if I'm announcing this or just making you aware that I'm working on what I call the Velour gem. This is a Rails generator. The idea is that it bootstraps an Omakase front end for your Rails app with a Rails generator. It does this by something. Oh, yeah, the mic. It installs Vite via Vite Rails, PostCSS via CSS bundling Rails. It creates a TS config file for TypeScript, not strictly necessary, but helpful if you want to go and configure it further. Hopefully you don't. It installs Overmind, which I think is a better version of Foreman. And along with that, it creates a better bin dev script with a debug option to make it easy to spin up your background processes, and which includes Vite, for example. And your Rails app in the front end or in the foreground. And it installs everything using npm for JavaScript, so no yarn. It also is available here. You can look at it there. It's a work in progress currently. I haven't published it yet. I kind of want to put more Omakase sort of things in it. But to do that, I really would like your help. I would like to know what you think the Omakase front end should look like in Rails. And we can have a conversation and produce this gem that then people can use to bootstrap this for themselves. I'd also like to mention one last thing, and that is that I'm also working on a Ruby-based front-end framework for when you really need true reactivity that lets you write your front ends in Ruby. It's called Wisdom. You can take a look. This is what the source code might look like if you were using Wisdom to write a front end. It has sort of JSX style syntax and can render on both the front end and the back end. So if you're interested in that, come talk to me. I'd love to chat about it. And thank you for coming. It looks like we have like a little over 6 minutes for some questions if there are any. Yes, right there.
I just wanted to ask what your thoughts are on NPM versus PNPM.
Yes. Okay. I unfortunately cannot speak to that because I've never used PNPM. I've heard lots of good things about it, so it's probably fine. By the way, I do want to say I'm not trying to say any tool is bad. I just personally have found the combination of tools I talked about up here more compelling than other combinations. So anyway, yes.
Hey Cameron, nice talk. I would like to know your thoughts about ERB, view components, and maybe Flex.
Yeah. Oh yeah. Oh my goodness. So many thoughts. I think components in general seem to be like a really powerful abstraction, or abstraction is not the right word, a code categorization system. I think React like really nailed that. I think that other language communities like ours are doing well to adopt that. Flex is amazing. If you like that syntax, definitely use Flex. View component with ERB templates. Also, it's sort of just a preference thing, I guess. Flex is also faster, so if you want to use Flex for pure speed reasons, that could be a good reason to use it. They both have great communities. They both enable this componentized sort of front end setup, and so I'm definitely in favor of all that stuff. Yeah, I didn't talk about that in this talk just because we're talking more about JavaScript and stuff, but yes, big fan of those things as well.
You were mentioning that importmaps is still not there. What do you think is missing for only relying on importmaps?
Yeah, that's a great question. So I think like the biggest reason in my mind to avoid import maps is not because, again, import maps are not bad. They're a great idea. But I think the big problem is if you want to do any form of transpiling or bundling or even the small, like even if you just want to use TypeScript, you have to use a bundler because you need the transpilation step, right? And so at some point when a browser sort of get native TypeScript support, then import maps could be a nice viable option. But I also think that like there are so many other dependencies that you might be pulling in, especially if you're using something like React, that either don't support ES modules or are incompatible in some other way. A bundler kind of papers over a lot of those problems. And so import maps, like you can get I would say 10% of the, my experience has been, you get about 10% of the way through building your app and you need a bundler for some reason, and there's just no option to do any other, like you're just literally dropping JS files from JS Deliver on the page, and like that only gets you so far, I think.
Since one of your main takeaways was to use Vite, can you expand on that a little bit more, instead of just using ESBuild for both production and development?
Yeah, so that's a great question. So ESBuild is amazing. I find ESBuild a lot more difficult to configure than Vite. I mean, Vite, especially with Vite Rails, is just so drop-in and turnkey that there's, for me, that's the benefit of it. It's the Omakase part. It's like I just drop this thing in, I run the install like rake task, and I can write some JavaScript. Like that's really the biggest thing, is like it's just fast and easy. And then of course ESBuild by itself is great. I think that eventually, like maybe we can just rely on ESBuild in the future, like when JavaScript kind of gets its act together, like everything works with ES modules. But again, based on talking about the previous question, like the bundling step is important because it papers over so many problems with different module systems and whatnot. And so, maybe at some point we can just use ESBuild and not even use rollup, because we don't actually need to bundle and transpile things. We can just send it to the browser, and that would be amazing. Hopefully we get that to that point at some time.
I was wondering if you have any favorite resources around structuring CSS in a project, or BEM primers, or that kind of stuff.
Yeah. I think with CSS, for CSS, my sort of intuitions, I'm not much of a CSS programmer, to be honest with you. Most of that at GitHub, for example, was done by other people. But the CSS that I did write and did see, it's like scoping that to components can be really helpful, because then you're not looking at a giant file. And then of course you have prefixing. That's one thing that BEM does really well, is it prefixes your CSS, or it encourages you to prefix your CSS with the name of the component. So instead of just saying, button color or something, you're saying .btn or .button dash, color, whatever. So you end up like having a more, I think, understandable CSS file per component. And then maybe CSS modules along with that, so that you're not namespace collisions. I think that that's like often CSS, in my opinion, gets really messy really quickly. So it's really just about like pick some system. It doesn't have to be BEM. Pick some system, stick to that, so that everybody knows how classes are written, how they're scoped. Maybe scope them to components using modules or something. Just do something, right? Like don't just have like a giant CSS file with everything in it, right? Okay, I have 28 seconds left, but maybe we'll just call it there. Thank you everybody for coming.